So here we choose m and n, and then we differentiate m and n. Remember that this only partial differentiation, so it is different from the ordinary differentiation. So Rn here is this. So we will differentiate this in terms of x. So definitely this is non-exact. And then between m and n we will choose what function is simpler. So here we will choose n. And we will follow this formula for us to get the integrating factor. This will become negative, this will become positive, so let's move these parentheses already. And then we will have 2xy squared minus 2y. This is to negative 2xy, negative 2xy, and then this is plus 2. We will distribute y here, then negative, and this will become, we'll have here negative 1, and then this will become 2xy minus 2 all over 2xy minus 2. Basically we will just distribute y here and then the negative 1 in the numerator so that we can cancel both the numerator and denominator. We can divide numerator, both numerator and denominator, and our final answer, negative y is equal to fy. And then to get our integrating factor, this will be our formula: negative fy dy, where our fy is equal to negative 1 over y dy, and then we will distribute this negative 1 to outside of the integral, so we will have integral dy, which is equal to ln y, which is basically y. So we have now our integrating factor, so that our function will become exact. We will distribute the y to the given function. Here 2x y cubed 2y squared dx plus 3x squared y squared minus 4xy dy. So basically after you get the integrating factor, you will just going to distribute the integrating factor to the given function. So this is now our new equation. So from our new function we will test if the given equation is exact. And then for our n, we will test also. So this is our n, 3x squared y squared minus 4xy, and we will have 6x y squared minus y. So basically the m and n here are exact, so therefore this is an exact equation already. So From exact equation, we will now integrate both m and n for us to arrive at the general solution of the new exact equation. So here we will have to integrate m to xy cubed minus 2y squared. This is dx. And then this will become f. And then here, we are integrating in terms of x, so we will let y, where the y variable as constant, so we will take out this y variable outside of the integral. This is basically x dx minus the integral of minus 2y squared, because it's basically in terms of x. So here we will have 2y cubed x dx x squared. So the integral x dx is integral over 2 minus 2y squared. Integral of dx is basically x plus q of y. We will simplify the equation. So we will have here y cubed x squared minus 2y squared x plus qy. So after getting the integral of n, we will now get the integral of n. So here's our n, 3x squared y squared minus 4xy, basically dy. Then the integral of this is f. This one is 3x squared y squared dy minus 4xy dy. And since we're integrating here in terms of y, we will distribute outside of the integral the constant in the variable of x. So you'll have here 3x minus y squared dy minus 4x, basically y integral of y dy. Then we will have here 3x squared. This will become y over 3 minus 4x y squared over 2 plus r of x. So we have here x squared y cubed minus 2x y squared plus r of x. And after we have, as we all know, we are going to find the value of rx here, the function rx and the function of q of x. So both the f's, which is the f of m and the f of n, we will equate them so that we can get the value of the function of rx and the value of q of x. So as you can see here, this term will become 0, and this term too will become 0. So basically, there's no term left here. So the function of rx is basically 0, and the function of qy is basically 0. And then we can substitute this to any of the value of 2f's. So this one we will equate the value of rx, which is 0. Is equal to f x squared y cubed minus 2xy squared. It's basically 0, so we will have our c. So this can be our general function, and we will also try this if two f's are equal. This is 0, so basically this is just the same. You can choose any of the two f's actually as your general solution.